Hi, everyone. Let me ask you a question. How many of you have smart devices, Internet of Things at home? Hands up. Okay. And if I ask that home router is also an Internet of Things? Okay, a little bit more. All right. Now, in this presentation, I'm going to show you what kind of vulnerabilities you can expect in your home network. So this is my name. This is where I work. And I had many different projects in my life. For example, I'm responsible for the zombie browser toolkit. I'm the developer of the hardware firewall bypass toolkit. Last year, I presented here my malware analysis sandbox tester tool. And last but not least, I invented the idea how bad guys can deliver exploits to endpoints in an encrypted way, which can bypass a lot of protections. Unfortunately, it turned out that the bad guys are reading my blogs, so they implemented this idea. But these kind of things happen. Unfortunately, this is not a 45-minute presentation, but it's planned for 60 minutes. So in order to motivate you guys to stay here, I have two very good reasons. And this is the first one, and this is the second reason. So there will be a question at the end of my presentation, and whoever can answer my question first can receive these. All right, so how did I get into this whole IoT security world? I bought an IP camera for home use, and I found multiple high severity issues in it, like backdoor accounts, remote command execution, clear text communication, all the usual stuff. And I have notified the vendor, and 1 year passed, but still no patch for this device. And the question is, now what? What can I do with this very horrible device? It is very hard to categorize what an Internet of Things is, but IP cameras, home routers, baby monitors, any smart home devices, or even a network-attached storage device or a smart car can be named as an Internet of Things device. Whenever we talk about Internet of Things, there are mandatory Shodan slides, and I also want to show you these Shodan slides. Shodan is basically a port scanner for the internet. And here I have searched for network-attached storage devices. And as you can see, there are almost 100,000 network-attached storage devices connected to the IPv4 internet directly. This is very bad. But you know what really bad is? If you search for cameras, and you can see all the cameras on the internet which are not protected by anything. You just go to the TCP port, and you get this picture back. I think it's pretty scary. For the next 5 or 10 years, I think it is very safe to assume that whenever you buy an IoT or smart device into your home, it will have very high severity issues. And if you are lucky, you can receive a patch for it, but most people won't patch it ever. So you can safely assume that it won't get patched at all. Also for this presentation, I assume that the IoT device in itself is not malicious, which is not always the case. The way I have created my presentation is that I have heard a lot of so-called excuses, what people tell me that, oh, their home network is totally safe, totally secure, because they have this or that. And I call these excuses, but if you collect all of these excuses together and you implement all of them, then at the end of the day, you can get a pretty secure home network. First of all, the excuses: I'm totally safe. I have changed all the passwords on my IoT devices, and it's not 1, 2, 3, 4, 5 anymore. Well, the problem is that there are many vulnerabilities in IoT devices which totally bypass the password protection. For example, there are memory corruption issues before authentication, like buffer overflow or format string issues. I will talk about cross-site request forgery later. For example, my IP camera, it has a backdoor account, which is not documented in the user manual at all. But if you try very weak usernames and passwords, you can find that it's there, and you can just log in to this device via telnet, and you get a root shell. Next excuse. I am safe. I regularly patch all of my IoT devices. Right? Unfortunately, most people don't test their IoT devices. There are so many different devices that it's impossible to test all of those. Even if they test it and they report it to the vendor won't release the patch, or if they release it, it's late by years. And even if they release it, the people won't patch their devices, so this is not working at the moment. Okay, whenever it comes to the risks in the IoT device field, I think the most important question is, how can the bad guys connect to my IoT or smart device? The worst thing can happen if you put your IoT device on the IPv4 internet. It gets an internet routable port, and anyone can access your device without any ports filtered. If you do that, just prepare for apocalypse, because nothing good can happen from this. And as I have shown you, you can see a hell lot of CCTV camera pictures on the internet. And because of this, now I think we should rename CCTV to OCTV, because it's not closed anymore, but it's an open circuit TV. And we have seen also in the very recent past that people can take over all of these IP cameras with these backdoor accounts and very weak passwords, and they can use it for DDoS, for example. So it's really, don't do that. Because if you put your IoT device on the IPv4 internet, it will show up on Shodan like a hooker on a highway. Next excuse. The IoT device is only available in a closed network, right? What can go wrong? If you remember the car hacking article from Charlie Mirel and Chris Walczak, you can remember that what they did is that this Jeep, it had a SIM card. And yes, the SIM card was in a closed network, but the closed network, what really meant is that it was a Sprint SIM card, and if you bought another Sprint SIM card in any shop, then you were able to access this closed network. So they were constantly scanning the Sprint network for Jeep devices. They were able to find their Jeep device, and through a lot of chaining of different exploits and vulnerabilities, they were able to control this Jeep. So this is sometimes what people mean about closed networks. Next excuse, I'm safe, because my device is only exposed to physically nearby devices, and I trust those. Well, actually, I think the risk is not that big, as it is the case with when you are on the open internet. But still, if the neighbor kid is a funny guy, then he can do pranks like this with your devices. It's not a big risk, but still. Whenever it comes to hacking smart devices through wireless, I think it's worth to mention that nowadays a hell lot of different devices are equipped with wireless access. For example, last year on DEF CON, researchers showed that even there exists a rifle which has a wireless access point, and Linux is running on it. And it turned out that all of these components were horrible broken, so you can just connect to the access point, then you get a root shell, and you can basically aim with the rifle. And I think the whole story was a little bit of fear, uncertainty, and doubt, but what you really have to see here that now everything is equipped with an embedded wireless device or Linux or something. The very next important topic is I am safe because I'm in my home network, and it is behind NAT, network address translation, so people cannot connect to my devices directly. That's good, right? Well, unfortunately, I think NAT is the sneaky evil, and users believe that they are safe because they are behind their home router, but meanwhile, the developers, they have created many, many different ways so people can still connect to these devices, even if they are behind NAT. So what could possibly go wrong? There is a false sense of security on one side and the reality on the other side. In this NAT topic, I will mention the case of UPnP, IPv6, Teredo, and the cloud connections. How many of you heard about UPnP? Hands up. Okay. And how many of you heard about Teredo? All right. UPnP is basically a setting on your home router, and on some routers it's enabled by default. And what it's good for, that whenever you plug in a new device on your home network and it wants to be basically physically exposed to the IPv4 internet, it can configure your home router to forward the ports to it. And it's totally automatic, which means that it's user-friendly, and which means it's not so secure. If we are talking about IPv6, I think it's a whole fascinating world, and I could talk about this topic for hours, basically. But whenever it comes to IoT, it's again very, very interesting. This story happened this year that there was a guy sitting at home, and he saw some very interesting incoming IPv6 packets to his home devices, which were IPv6 enabled. And he started to debug what happened. And it turned out that whenever he starts these IoT devices, or even periodically, these devices check for the internet time through NTP protocol. And because IPv6 was enabled, it was the default network protocol to be used. So it connected directly to some IPv6 NTP servers. It turned out that some of these servers were a little bit malicious, and they started to collect the IPv6 addresses of these devices. I'm sure all of you know that you cannot scan the IPv6 internet the same way as you can scan for the IPv4 internet, because the address range is so huge that you cannot do that. But whenever you can log the IPv6 addresses of these devices, you can sell it or you can forward it to your own servers, and these servers can start to scan these devices for new ports. And in IPv6, there is no net, so they can connect to these devices directly. Luckily, from the NTP servers, these malicious servers have been removed, but I think this really tells us how the future will look like. I think in the future, there will be a market for private IPv6 addresses. I'm not sure how many of you are familiar with these terms, but whenever you use IPv6 as a client, you will get two IPv6 addresses, one static one and one so-called private one, which will change usually every day. And the reason for this is that your IPv6 address won't become a super cookie to track you on the internet. But when we look at the current trends, if you visit a new site, you get 30 or 60 new tracking cookies. then I'm pretty sure that some of these tracking sites will also sell your IPv6 address to the bad guys so they can scan you back. And this is really, really scary. Whenever we talk about IPv6, it means that your device has to be reachable from the outside via ICMP, because this is the way how IPv6 works. And this can also lead to some exotic hacks, like if there is a vulnerability in the network stack, for example. When I told you that it's not possible to scan the whole IPv6 internet, although I was telling you the truth, but there are some ways how you can find some of these devices. For example, whenever people choose these IPv6 addresses and it's not totally random, then you can predict it, like it's a very small number, or it is basically mapped to a service port, or it's a funny name, or it's the translation. The second part of the IPv6 address is translation of the IPv4 address, etc., etc. And whenever we talk about enterprise environments, then there will be a lot of different ways to enumerate these IPv6 addresses through DNS, like reverse DNS enumeration, zone transfers, DNSSEC, DNS brute force, and so on and so on. If you are interested about this whole IPv6 security world, I really recommend you to watch Mark van Hauser, IPv6 Security Revolutions talk. It's really, really interesting. Next interesting topic is Teredo. Teredo is a protocol implemented in Windows since God knows when. And the reason it was created because there will be clients in the future who will have no access to the IPv6 internet, but still there will be servers on the IPv6 internet which has to be reached somehow. And the way Microsoft developed this Tredo protocol is a two-phase protocol. First of all, the Windows client is constantly sending some keep alive messages to a remote Microsoft server. And because it's a packet which is always active on the router, the Teredo server is now able to connect back to the Teredo client. And if there is another IPv6 peer on the IPv6 internet which wants to connect directly to this Teredo client, then they will be able to do that. How? You might ask. The Teredo IPv6 addresses have a fixed prefix, so whenever this client wants to connect to the Teredo client, it will be routed to this Teredo relay. The Teredo relay will know which Teredo server to connect to, which is in live connection with this Teredo client. And now the Teredo server can tell the Teredo client that, hey, there is an IPv6 peer which wants to communicate with you. So please try to connect to this IPv6 peer through the Teredo relay. And after this connection works, then the IPv6 peer and the Teredo client can communicate, even though by default one is on the IPv4 internet, the other one is on the IPv6 internet, and the client is behind home router net. Not many people know about this Teredo thing. The very first interaction of mine with Teredo was when I saw IPv6 addresses in my torrent client. And as it turned out, the uTorrent developers figured it out that people don't have to use port forwards and the UPnP and things like that in order to have a better torrent connection. So they started to use Teredo itself. And whenever they implemented this feature, the Arbor networks measured the IPv6 internet traffic, and it caused a 15-fold increase in IPv6 traffic itself. Now, let's talk about the IP camera cloud hack. This research is still a work in progress. There are some details which I have to research, but I need time for that. The interesting part for me from this camera was that even though my camera is in my home network and UPnP is disabled and I have not configured any port forward to this camera, still I am able to reach the camera image through this Android or iOS smartphone application. And the question was, how the heck can I do that? How can I connect to my camera? As you know, if both devices are behind NAT, it's basically impossible to connect these two devices together without the help of a cloud server, which can act as a broker to set up the connection. For example, if you think about how TeamViewer works, they are using a server so both clients can connect to each other. Now, as it turned out, my IP camera is also using a cloud server, so this cloud server can help to set up the connection. And this whole protocol really reminded me how Teredo works. If I turn on the camera, it will start sending UDP keep alive packets to this cloud server, which is sometimes in China, sometimes in South Korea, you know. And whenever I start my client application to watch the camera picture, the first packet is sent from my mobile phone to this cloud server, and it only includes one thing, my camera ID. It's not an encrypted protocol, there is no authentication in it, nothing. I just send a camera ID to this server. The response is, if it's a valid camera IP, with three IP addresses. The first one is the local IP address, which I can connect to if we are on the same LAN network. The second IP address is the publicly accessible IPv4 address for this camera. And the third one is a cloud server IP address if both devices are behind NAT. And if my mobile phone first starts to connect to these local IPv4 address or the public IPv address, by default, it will get dropped because the home router will close the connection because there is no port forward configured. But what's really interesting, that meanwhile, the cloud server can notify my IP camera that, hey, there is a client here who wants to communicate with you. What do you think about this? And as it turns out, that now the IP camera is sending a packet to this mobile phone. And for example, this mobile phone has a public IPv4 address and it's not behind NAT. The camera connects to my mobile phone. From this point, I have started to work on my own client, which is implemented in Python, and I have used a server for this. So for me, it was not an issue to get this packet. Now, I have a communication channel between the camera and my client. What's the next step? I should authenticate to this camera, right? By default, the username for this camera is admin. What a surprise. And the password is 4 characters, but only numeric letters. So you can guess that how hard it is to brute force this camera password. And unfortunately, there is no brute force protection in the camera itself, so you can keep trying and trying and trying until you find the good password. But it gets worse, because the whole protocol is clear text. Whenever I start my mobile application and I authenticate it to this camera, guess what? The camera will send the whole configuration to my mobile phone, which includes Wi-Fi password, which includes my credentials to my email server, which is used for alerting. It includes all the passwords to my FTP server, where all the images are uploaded. Pretty cool, huh? So if you are at the airport, checking your camera picture, not just your camera password will be stolen, but also your Wi-Fi password, email password, and FTP password. Really cool. This is just a small code snippet, how my Python script works. Unfortunately, I won't release this code. Most of the time, I release my offensive code, but this is, I mean, if it's never get any patches, why should I release it? So it doesn't really make sense. But let me show you how this script really works. So here in my server, I start this Python script. And first, it will authenticate. It won't authenticate. It will connect to the cloud server with camera ID. And I got back the reply from the camera. So now I can talk to it. And I can start to brute force the password. And unfortunately, at the moment, it's a little bit slow because there is no way to start the authentication process. Only you can start it from the beginning where you start connecting to the cloud server. But it can be also multi-threaded and things like that, so it's not that bad at all. And my script is trying different passwords. And at the end, it starts password 1337, and I get back the authentication reply from the camera that, cool, that was the good password, finally you found it. Now we can communicate, and I can share your Wi-Fi passwords with you and the whole world. Next security excuse. I am safe. My network is super firewalled. None of these apply to my network. Right? It makes sense. I know a lot of you know guys who are really into firewalling and they filter everything. Unfortunately, there are still ways to hack these kind of networks. I'm not sure if you can see it on this slide, but this is an HTML code from a website, and it basically brute forcing the IP addresses of your home router, and it has all the default passwords for this home router, and via only a single HTTP GET request, it's trying to reconfigure the home router DNS server addresses. And whenever the DNS server is controlled by the attackers, then your connection can be attacked via man-in-the-middle attacks, right? And how can this happen? Your browser downloads an HTML file, it starts to process it, and from now on, your browser is attacking your home network, right? In order to prevent these kind of attacks, I really recommend all of you to install an ad blocker like uBlock into your browser. And for example, in my home network, I use 2 separate browsers, one for internet access and one to access the internal network. And the one I use for internet access is using this uBlock ad blocking software, and I have added some custom rules, so it will think that everything inside my home network is an ad network, so it won't connect to it. So it's a very, very basic and stupid firewall. Next excuse. I am safe because I have changed my network range in my home network, so people cannot brute force it the way you have seen in the previous attack. I have some very bad news. How many of you heard about WebRTC? All right. So WebRTC is an API, and it has been developed to support browser-to-browser applications for voice, video, and peer-to-peer file sharing. What does it really mean? You can basically do Skype in your browser without any plugins. And in order to able to create a tunnel like this between two browsers, which might be both of them behind net, it is important for the protocol to get the internal IP address of the browser, which means that whenever a user using a browser visits a website which supports WebRTC, through the WebRTC protocol, your internal IP address will be leaked. And actually, this whole protocol is supported in Chrome for almost 4 years, since 4 years ago, and all the other browsers started to support it. Most of the time in the mobile browsers it's not implemented, but in all of the desktop softwares. So I'm going to show you a quick demo how these different kind of attacks can be chained together in a single attack. For this demo, I have installed an old vulnerable FreeNAS device on my home network. What's really interesting here is that this FreeNAS device had no authentication on this admin panel, and there was a shell window, which whenever you clicked it, you were able to type shell commands into the FreeNAS device with root privileges. What could possibly go wrong, right? So this is how my attack is implemented. Me, the evil attacker, is setting up a browser exploitation framework server on the internet. And let's say that the home user on the left is browsing the internet. And either I can convince him to visit my website, or I can find a cross-site scripting vulnerability in one of the websites he visits, and I can inject my own JavaScript code into this website. And now that my malicious JavaScript code runs inside the home user browser, I will be able to leak the internal IP of this browser. Now that I have the IP, I can start to port scan his home network. And whenever I find vulnerable devices, I can start to attack them. Now, let's see it in action. OK, so here you can see that I did set up a netcat server listening on my attacker server. And this is the website where I have put some interesting content so the user can watch it for hours for his own entertainment. And here you can see the very simple JavaScript one line injected into the website, which implements a very complex JavaScript itself, but now it's only one line. Now, let's see what the attacker can do. Here, in the browser exploitation framework, I have a new client. And first, let's try to leak the IP address with WebRTC. Execute the command, and there you go. I got the IP address of the browser. Now I know which range I have to scan, right? So I go back. I search for the port scan module. Unfortunately, the default port scan modules didn't work for me in Beef, so I had to fix it. But now it works, at least for me. So let's port scan the internal network. You can see that it's a little bit slow, but again, this can be fine-tuned, this can be multi-threaded. So, and if the user is watching a 1 hour-long video, then it's not that slow at all. So I am port scanning his internal network for open devices, which has a web server. And there it is. You can see that on the 106 IP address, I have found an open port. Now, the next logical step would be to fingerprint this device, which more or less works, but it's a little bit buggy. So let's say that I have found 0 day, for example, and I know everyone is vulnerable, and I'm just blindly exploiting every open port with this vulnerability. So here I just have to type the IP address of the vulnerable FreeNAS device, the HTTP port, and I have to specify the IP address of my connectback shell and the port for this, right? I click execute, and I got my shell back, which is a root shell. So this is what can happen in a super firewalled environment. Okay, next question. How many of you know what SameOrigin policy is? Hands up. Okay, good. SameOrigin policy is basically a security boundary which prevents one script accessing the content of other web pages. For example, if you are using webmail and there are some advertisements on the webmail, you don't expect that this advertisement can read your emails, right? So what really happens is that if the script or content is hosted on different host, port, or protocol, then the browser will separate these contents. If there is a security boundary, then hackers will try to bypass this security boundary. And one of the ways to do this is the DNS Rebinding Attack. Again, this DNS Rebinding Attack is a very huge topic, so I don't really want to go into the details. But what really happens here is that the attacker is registering a domain name with a private IPv address, which will be attacked, and with a public IPv address, which will serve the malicious scripts. And first, the victim will connect to the public IPv address. It will serve this malicious script, and later on, through different methods, the public IPv address won't be accessible, so the client browser will start to use the private IPv address, but with the malicious JavaScript. This whole array is a cat and mouse game since 1996, so it's really, really old stuff, but still in the past there were new ways to circumvent this. There is a very, very interesting attack already published called Filet-O firewall. So if you are interested in this kind of topic, I really recommend you to visit their website and check their scripts. What they are basically doing that through this DNS Rebinding Attack and different vulnerabilities, they can hijack your router, and they can configure all the port forwards in the router, and basically they can open your whole internal network to the outside world. All right, but what kind of attackers can you expect on the internet? There are, of course, a lot of script kiddies who will do things for fun. And I'm sure that this will cause some interesting news every day in the future, what script kiddies can do with hacking IoT. But I think this is not the biggest issue here. If you are talking about political activists, I don't really expect much here. But if you are talking about organized criminals, I'm sure that they will implement attacking IoT devices in their attacking scenarios. For example, we have already seen in the past that some of the network-attached storage devices had some very, very bad remote code execution attacks. So the bad guys basically encrypted the content of these network-attached storage devices, and they were demanding a ransom for this. If you are talking about smart homes and burglaries, might be that if you have a very luxury house, then the burglars will start with hacking your smart home. And as it turns out, it's not that hard at all. If you are talking about, for example, internet-connected cameras, you can see that it can be used for spying, or it can be used in DDoS attacks, which is really, really bad. There was also a case, I think, this year that a smart car had a wireless access point, and through this wireless access point, the thieves were able to steal this car. Really, really interesting. And of course, people can use these IoT devices to send spam out. Whenever we are talking about nation-state attackers, I think these IoT devices really fit into their collect everything strategy, because they always try and track and profile people. But I think there are two new adversaries in this game. The first one is the advertisement industry, who are basically selling you cheap smart devices, which will be cheaper than the traditional non-smart device, just because through the profiling and tracking of people, it's economically profitable for them to sell these devices cheaper. Also, what people tend to forget, that most of these smart devices are so dependent on the cloud that whenever the cloud server is turned off, then the IoT device doesn't work at all. For example, there was a very sad case, I think last month or 2 months ago, when there was an internet connecting pet feeding machine, and the servers went down, so the cats and dogs didn't receive their food while people were on holiday. And the problem is with most IoT devices that sometimes you just pay a one-time fee when you buy this device, but you don't pay any monthly fee for this device. So what this means that after 2 years or 3 years or 5 years, it won't be basically profitable for the manufacturers to operate all of these servers. So they will just shut it down, and your device won't be able to work anymore. In a utopistic world, IoT development guideline would look like it's secure by design, tested for security, and patches are released if security issues are found. In reality, at the moment, none of these apply, because the current guideline that it has to be cheap, you have to be first on the market, you should embed some Linux or BusyBox into it, and most of the time, people embed web servers or VNCs into these devices, and most of the time for no reason at all. And this makes me really, really sad. I have talked about the different network connectivity risks, and there is a huge gap whenever your vulnerable device is directly connected to the IPv4 internet, and whenever we talk about these very exotic and multi-step attacks. And I think what you can do that if you do most of my recommendations, which I will collect during the following slides, that you can reduce the risks of your home network. For example, my IP camera, it's disconnected from the power cord whenever I am at home, and I only turn it on when I leave the house. And if you don't need your IoT device to be available 24/7, then you should just turn it off. If there is a patch, you should patch the device, but I don't expect much from this. Surely you should change the passwords of the devices, and it's preferable to use complex passwords and don't reuse the passwords. You all know these. You should check your home router and disable direct inbound connections if you don't need that. I really recommend to disable UPnP on your home router and configure all the port forwards for you manually. If your ISP provides IPv6, then you should also check not for IPv4, but IPv6 traffic. If you use Windows, I recommend you to disable Teredo, because most of the time you won't use it, and it's just a security risk. If you have a lot of time and you find checking gigabytes of Wireshark logs fun, then you should monitor for tunneling protocols in your home network. I have already showed you how you can use uBlock ad blocking to prevent from these cross-site request forgery attacks from your browser. Again, if you have a lot of time, you can scan your home network for new devices. For example, when I moved to a new flat in the past, it turned out that I was living in that flat for 4 months when I found that the set-top box with the TV had a wireless access point itself. So it was really strange for me that, oh come on, there is a new Wi-Fi access point in my home network. I didn't know about this. And yes, it was running with default credentials. I think you should also separate your guests from your IoT network, and not just your guests, but also, if possible, then you should separate your home network from the IoT network. For example, what you can do that use an old home router and connect all of the IoT devices to this home router, and connect this home router to your real router, which you use regularly. If you can, you should disable WebRTC in your browser. For example, if you install the WebRTC network limiter extension into Chrome, then you can disable it. If it's possible to disable the cloud connection from the IoT device and you don't use it, you should really turn that off. Or if you can't turn that off, then try to filter on your home router firewall. In order to prevent DNS Rebinding attacks, you can do a lot of things. The basic idea is that whenever you get DNS responses from the internet, then you should filter out the private IP addresses, because there is no legitimate way when you get private IPv addresses from a public DNS service. And you can use, for example, OpenDNS for that, or the Firefox NoScript extension, or you can configure your own firewall for that. So it is said that smart devices will make our life easier, right? I think maybe in the future, yes, but until then, these devices will make our life a nightmare. And my best advice is that you shouldn't really buy IoT devices or smart devices at all, because most of the time you don't need this thing. Some of the devices are so dumb, and it's just for marketing purposes, and it's not for you. If you are an IoT vendor, you should do all of these things, but I believe none of you are developing IoT devices at the moment. If you are working for the government, then I think you should follow what the Federal Trade Commission did in the USA. They basically fined ASUS because ASUS delivered very horrible, vulnerable home routers to the users, and they never, ever tested these routers, against security vulnerabilities. So there was a huge fine against ASUS, and I think it's really a good way to start something in this field. If you want to have a look at very, very interesting and fun IoT devices you can find on the internet, then I highly recommend you to Google for a presentation from Dan Tantler. The title of his presentation is 115 batshit stupid things you can put on the internet as fast as you can. It's a really, really amazing talk. I highly recommend you to watch it. It's better than any movies nowadays, really. Before our game with the beer, I would like to show you two very interesting quotes, which I find really, really, how could I say, both sad and true. That there is no cloud, just other people's computers, we know that, but there is no Internet of Things, but just other people's computers in your house. And the problem with building a smart home is that you end up with a mini data center, minus the admin and the security folk. And I mean, if you have a hell of a lot of time to do this, and this is your hobby, do that. Otherwise, don't, really. All right, question is, if you are the first one to answer my question, what was the first IoT device in history? Yes? Louder, please. Almost a coffee machine. I will accept your answer, actually. It was a Coke machine. So, but you can pick your beer after the presentation. So that's all, folks. That's all I wanted to share with you. Be safe at home. Thank you for your attention.